how would you like it? So we were given pressure, volume, temperature. 1.04 ATMs, 45.1 liters.
Are you going to say what if we did? Yeah.
And 34 degrees Celsius, or what was it, 307? Okay, so we were given those things, but we were asked for the mass in grams. And we knew that it was CO2, so we were able to figure out, what, 44.01 grams per mole. But we didn't get moles.
Wait, what did you just do?
I just filled in, this is sample problem number 1 on 345.
Little m and big M.
So little m is mass,
Molar mass.
big M is molar mass. Big M is molar mass. Mass in grams is the mass of a sample. Big M is molar mass. So what we had done was we took our mass in grams. Oh, mass in grams is what we're looking for. So we figured out moles. We used PV equals nRT to figure out moles. Then we plugged that into a factor label, right? Would you like it if there was a way to do that in only one step and you didn't have to do a factor label in addition? Okay. She asked the right question. What's the price? There's always a price for magic. Okay. So, if I tell you that I have 100 grams of pure carbon, can you tell me how many moles that is?
100 grams?
Yeah. If I give you 36.7254 grams of nitrogen, can you tell me how many moles it is?
Yes.
Yeah, of course you can. Because you know that the number of moles equals the mass of the sample divided by the molar mass, right? You know that. So N, which is number of moles, equals little m over big M. Well, guess what we can do? We can take this and we can plug it into the ideal gas law. So we now have Peaceful Valley equals little Mert over molar mass. Okay. Do you want the algebra clarified on that?
Where's the mass?
Mass of the sample over molar mass times RT.
Oh, I see.
Okay?
I see how this works.
So then we can multiply this across. So we have PV equals little m RT all divided by molar mass. So now we can do that problem and we don't have to do a factor label. So let's do that problem again. We're going to put up here PV equals little m RT over big M. We're solving for mass of the sample. So we now have PV times molar mass equals mass of the sample times RT, divide both sides by RT, and we're good. Okay. Let's see if we get the same number. We should. Pressure, 1.04 ATMs, 45.1 liters. What units is molar mass in? Grams per mole. That's real important. 44.01 grams per mole. And we're dividing by our gas constant. We're in ATM, so we're going to use 0.0821. 0.0821 ATM liters over mole Kelvin. And our temperature is in Kelvin, 307 Kelvin. This whole thing should equal mass. So let's check our units. A different color here. Atmospheres cancel. Liters cancel. Moles cancel. Kelvins cancel. What are we left with? We're looking for mass. Does that work?
It works.
Okay, what's your raw number?
81.8992108.
Okay, so something that's going to sig fig to 89.9 or 81.9. Same number. But I think that's a little bit simpler, don't you? So now we have two different versions of the ideal gas law. I'm going to write them both up here. We have Peaceful Valley equals NERT. We have Peaceful Valley equals little MERT over M. So we've got two versions. This is good. This is good. So now, do you sense something else? Question.
Going through all of this one we got 81.9.
Mm-hmm.
The other one we got, when it all figured out, it ended up being
It did.
82.
It ended up being what?
82 when we finished figuring it out, because it was 81.99.
99. And that one we got a slightly different number. Right. We're gonna have a 1/10 of a difference in the final answer. Yeah.
Okay.
Yeah, absolutely. Well, the same thing. If you do one as a factor label using 22.4 liters at STP versus taking all those same numbers and plugging them into the ideal gas law, sometimes you will get a slight difference in your answer. What you need to show me on a test is that you used all the full numbers, and one of them is actually slightly more precise than the other, undoubtedly. So we should have gotten the same exact thing though if we used all the same numbers. On that one, we should have gotten the same exact thing. Why wouldn't we?
My raw was 81.899.
Yeah, that's what mine.
899. Okay, and that's the same thing then. That's going to sig fig to 82.
I didn't.
And this thing even bother too, the whole thing.
Okay.
Were you like rounding all the way through, or
Yeah,
no, you
don't
raw?
ever round till the end. Yeah, actually, come to think of it, you should get the exact same thing. Sometimes we see a difference with ideal
I got
gas
the-
constant,
I got 0.89.
0.899, and that would round to 82.0.
No, I mean,
Oh no, it wouldn't.
no.
Hmm.
Oh,
I was
around
trying to
82.
tell you that.
Oh,
This is
okay.
truly a
I was
puzzle.
trying to show
Truly
you
a
what I
puzzle.
got.
Okay. So we've got a slight difference in sig figs. We'll have to see why.
Wait, what's the answer supposed to be?
Okay.
82?
81.9.